Today, on how it's made. Automatic transmissions. Gearing up for production. Silver miniatures. At this factory, scaling down means business is good. Hot air balloon baskets. The sky's the limit. And darts. We get right to the point of this story. The transmission in your car transfers power from the engine to the wheels by setting the most appropriate gear for your driving speed. With an automatic transmission, the driver doesn't have to shift gears manually. Through various sensors, the car's computer determines when it's time to shift and sends an electronic signal to activate or deactivate the appropriate gear. The transmission is a system of gears and levers that transfers power to a car's drive wheels while allowing the engine to operate in its most efficient range or power band. It's assembled inside an aluminum housing called the transmission case. At the heart of the transmission are 3 sets of planetary gears, the term for smaller gears rotating around a larger central gear. The first gear set is called the final drive. It harmonizes the engine speed and driving speed and is attached to the differential, a component that lets the wheels move at different speeds so the car can turn. They install the steel parts connected to the shift lever, which puts the car into drive, reverse, or park. First, the manual detent lever. Then the forward clutch support. This piece protruding from it is called the park pawl. The actuator rod connects the detent lever to the park pawl, which locks a gear that immobilizes the car when you shift into park. Now for the transmission's 5 clutches. Clutches either let gear sets rotate or lock them, depending on what the transmission needs to do. This clutch is called the forward clutch. It enables the car to advance when you shift into drive by moving the 2 remaining planetary gear sets, called the input gear set and the reaction gear set. 2 clutches, installed as one unit, go in next. The coast clutch controls both the input and reaction gear sets, enabling the car to coast in low gear and progressively brake in higher gears when you take your foot off the gas. The other one is called the direct clutch, which locks the 2 gear sets so there's no reduction in speed. Next, the reverse clutch. When in reverse, it moves the reaction gear set, enabling the car to back up. A clutch is made up of layers of metal and friction material, such as resin-impregnated paper. The transmission's last clutch is called the second clutch. It uses both the input and reaction gear sets to switch the transmission into second, third, and fourth gears. With all the gear sets and clutches now in place, workers can connect the transmission to the rest of the car's electronics. These cables are known as the harness. Next comes the drive chain and 2 sprockets. This hookup is the critical link between the transmission's gear sets and its torque converter. The torque converter is the component that transfers power from the engine to the transmission. The sprockets, along with the final drive, convert the engine speed to the appropriate transmission gear. The car's computer directs this hydraulic control system to change gears as needed. The computer triggers an electronic switch, called a solenoid, to open a specific control valve. This applies hydraulic pressure to engage the clutch around the relevant planetary gears. The system releases hydraulic pressure to disengage the clutch and lock the gears. Now the final connection for the shifting mechanism, linking this manual valve to the detent lever. The shift lever moves the detent lever, which makes the valve direct hydraulic pressure accordingly. This steel bar, called the output shaft, directs transmission power from the final drive at one end of the transmission to the driver's side front wheel at the other end. Next, they install springs and servos, part of the hydraulic control system that help engage and disengage the clutches smoothly. This tube assembly goes in next. The control valves route hydraulic fluid through these tubes to the different clutches. Now the torque converter. It spins a shaft that turns those sprockets and drive chain we saw earlier. A steel bar called the stub shaft is the final link, sending transmission power from the final drive and differential to the front wheel on the passenger side. Collecting miniatures and displaying them in dollhouses isn't just child's play. It's become a serious hobby for grown-ups, who even buy fine silver in miniature. They spare no expense, because after all, it's the little details that make the difference. In the world of miniatures, there's no need to downsize one's expectations. Here you can find all the little luxuries, like fine silver that isn't just a cheap reproduction. This silverware is a tiny version of the real thing. To make it, they use silversmithing tools and techniques that have been handed down over generations. This is a workbench used in the 18th century. Today, they use one that's nearly identical. They measure a full-sized mug and divide the measurements by 12, giving them specifications that are 1/12 scale, but true to the original. Next, they squeeze a strip of silver between rollers, which thins it out to about a ½ millimeter. Then they punch small round shapes from the silver. A blast from a torch softens them, which makes them easier to work with. They plunge them into acid, which eats away impurities and leaves a frosty finish. Next, they spin one of the silver discs on a lathe, and using a series of tools, they shape it into a thimble-sized mug. Any mistake is a big one when you're working with such small dimensions. It could ruin the whole job, so they work with great care. The machining also removes the frosty finish left by the acid wash for a truly sterling result. They buff up the mug to add luster to the finish. Next, they make a mini silver base for the mini mug. They taper it so it will be a perfect fit. They place small fragments of silver solder between the two pieces. Then they heat the parts to 770 degrees Celsius to fuse them together. Next, they cut up leftover silver and put the scraps in a crucible. They add a pinch of borax, a mineral that will prevent unwanted oxides from forming, as they melt the silver leftovers to a molten mass. Melting the scrap will enable them to reuse it. They pour the molten silver into a plaster mold of little handles. Then they plunge it into cold water. The temperature change causes the plaster to explode, exposing the mini silver handles. They solder one onto the little silver mug. And now it won't slip through your fingers quite so easily. Next, the miniatures are cleaned and polished by friction in a bucket of steel shot and soapy water. They strain out the soapy water, revealing the gleaming miniatures. Each silver miniature has to meet the same standards of purity as full-sized silver. Here in Britain, the regulations have been around for 700 years. The maker's mark, called the hallmark, is the stamp of authenticity. Hallmarking a miniature can be a bit awkward, and sometimes the article is just too tiny to mark. But when it comes to replicating silverware, it seems no job is too small, and there are plenty of shining examples in the world of miniatures. Did you know that some hot air balloon baskets are more than 6 meters long and carry more than 30 people? The bigger the basket, the more passenger compartments it has, preventing people from toppling over each other during bumpy landings. The partitions, meanwhile, strengthen the basket's overall structure. Hot air balloon basket weaving 101. First, you build the frame. Workers cut pieces of tubing made of stainless steel. They manually round the corner pieces, then assemble the frame by welding all the parts together. They cut a sheet of plywood for the floor, then drill holes in it for stainless steel support cables. The cables reinforce the floor against the weight of the passengers. After marking off the area that the basket walls will occupy, workers run the cables under the floor, lying upside down, leaving extra on both ends to come up the sides of the basket. Then they notch a groove, the width of the cables, in runners, lengths of ash wood that protect the base of the basket and give it rigidity. After bolting the runners down, workers use a branding iron to burn the company logo into the floor. Then they spray on a coat of lacquer to prevent moisture from rotting the wood. Larger baskets need diagonal reinforcement cables for extra support. The basket walls are made of cane, the stiff stems of a tropical Asian plant. The cane soaks overnight in a water tank. By morning, it's supple, and the weavers can begin their craft. They start by installing uprights, attaching each one to the frame at the top and bottom with a thin piece of cane. Then they feed the support cables from the floor up through the frame. The uprights are 45 centimeters apart along the sides and 10 centimeters apart around the corners. The weavers fill the gaps with thinner uprights every 5 centimeters. They tie them to the frame and floor with rope. With all the uprights installed, it's time to build the basket walls from the bottom up by interlacing horizontal canes. A pair of weavers can finish a small basket in a day, whereas large baskets can require a 4-person team and take up to 3 weeks to weave. They use 2 techniques: randing, going in and out with 1 cane, and whaling, weaving 3 canes at once. Whaling makes a more solid basket, but one that's significantly heavier because it requires triple the amount of cane. Some models have stainless steel steps woven into the basket. These give passengers a foothold when climbing in. The weaving ends just below the top of the frame. To finish, they split the remainder of each upright down the center with a utility knife, then flatten and wrap what's left around the frame. The weavers integrate rope handles at the top of the basket, giving passengers something to hold on to during the ride. They also put handles at the bottom for carrying the basket. Now they pad the frame with foam, cutting holes to let the support cables through. The foam is for both comfort and safety. It cushions the hard metal during a bumpy ride. After taping the foam pieces together to prevent shifting, they slip on a leather cover, then thread a polyester lace through the eyelets to close it up. Finally, with a few bangs of the hammer, they expose the short tubing to which the load frame will connect. The load frame carries the burners high above the basket. A heating coil surrounds each burner. To make it, they wrap a stainless steel tube around a form, then rivet on a reinforcement band. The basket carries lightweight fuel tanks containing cold liquid propane. The propane flows upward into the coil. When the pilot fires up a burner, the flame heats the coil, transforming the propane flowing inside from liquid to gas. The gas feeds the flame, which heats the air inside the balloon. Hot air is lighter than cool air, so the balloon responds by rising to the occasion. The game of darts dates back to the Middle Ages, when English soldiers, looking for some fun, began pitching arrows at the bottom of an empty barrel. When winter came, the soldiers moved their game indoors, but they couldn't throw big arrows around inside, so they used shortened versions, and the game was on. With these little missiles, you can give this game your best shot. They start by making the flight shafts. That's the piece that the dart's wings are attached to. They load 3-meter aluminum rods into a machine that has several cutting tools. The tools work from many angles on one aluminum rod at a time. They shape the rod into dozens of shafts. The tools cut threads and hollow out one end of each shaft to allow it to be screwed onto the dart barrel later. A cross saw cuts slots in the other end for attaching the wings. Oil flushes away the shavings, and it also keeps the tooling cool so it stays sharp enough to cut through metal. The completed shafts fall into a bin to await further assembly. Next, they load brass rods into a similar machine. Its tooling carves the brass rod into barrels. That's the main part of the dart that you grip. They thread and taper one end to allow the shaft to be screwed onto it. The tapering also makes the dart aerodynamic. Next, tools with angled grooves cut ridges on the outside of the barrel to make the dart easier to grip. The process is called knurling. Another tool then cuts the brass barrel to the correct length. They also make dart barrels from tungsten, which is quite dense, so the barrels can be cut slimmer. Slimmer darts can give you an advantage in tight scoring situations. It's why the pros often prefer tungsten darts and have them custom made, even choosing their own knurl grip. These are knurling wheels. It's another way to etch the grip pattern into the dart barrels. Knurling wheels come in an assortment of patterns, all designed to help you keep a grip on your game. And now, production takes a very sharp turn. They force a pointed steel tip into the hollowed end of the dart barrel using a hydraulic press. With the point now snugly in the barrel, this dart is ready for its wings. They're made from polyester film, which first winds through printing rollers. Some print jobs involve just one basic color, while others layer many colors to build up a design. In the world of darts, the wings are known as flights. A machine cuts out the flight shapes, and they accumulate in big piles. Flights are made in various shapes. This is just one. They fold the cutouts together to make a flight. They check each one for symmetry, because an out-of-proportion flight could affect the game. Now it's time to screw the shaft to the barrel of the dart. They slide the polyester flight into cross slots on the end of the shaft. And this set of darts is now ready for its target market. It takes less than a minute to make a dart. Not long when you consider a good set of darts will provide you with an infinite amount of entertainment.